Okay, we're taking a look at lesson 6-6 and we are looking at problem 4. Before we do, we're going to look at the combination notation. So the expression NCR represents the number of combination n objects chosen R at a time. So the formula would be NCR equals n factorial divided by R factorial times n minus R factorial. If you remember the combination formula, which is here, notice that there's no R factorial right here for the permutation. So that's the difference for the permutation formula and the combination formula. Now, something that I also feel like the book did not do an adequate job of explaining is the difference between the combination and the permutation. So, please indulge me for just one quick moment. So, permutation, order matters. Okay? And then the combination, order does not matter. The easiest way for me to think about it is the permutation is like and I know this is going to be opposite of what we think about, but permutation refers to a combination lock. So if you had a locker at school or you have a combination lock for your bike or any type of thing, that is what permutations are for. So let's say that you have 9 numbers to choose from and you have 3 slots to fill. Well, you need permutation because order matters, because 3, 2, 1 is not the same as 1, 2, 3 if you're putting it in your combination. So order matters for permutation. Combination, order does not matter. So this is like if you want to choose people to be on your football team. It doesn't matter how you choose them, which order you choose. If you choose Mike, John, and Dave, it's the same as Dave, John, and Mike. It will be the same team, right? But if you want to choose Mike, John, and Dave as president, vice president, and treasurer, well, now it matters. And so now that would be a permutation instead. So that's the difference between a permutation and a combination. And that was my quick little lesson on it. So let's take a look at problem 4. It says 20 people report for jury duty. How many different 12-person juries can be chosen? So here, it doesn't matter the order, right? The order does not matter. Like I said, if I pick Tom, John, and Mike, it doesn't matter if I pick John first or Tom first or whoever. They're all still going to be on that team. So it's a combination and the order doesn't matter. And so that would be 20 is my N and 12 will be my R. So that would be 20 CR, C12, which is 20 factorial over 20 minus 12 factorial times 12 factorial. Okay, so that gives me 20 factorial over 8 factorial times 12 factorial. So if I wrote it out, I'm using my finger, so please forgive me if it's a little sloppy. I have 20 factorial, 20 times 19 times 18 times 17 times 16 times 15 times 14 times 13 times, I'm going to stop at 12 factorial because I have a 12 factorial down here, right? So I have 12 factorial. I'm going to go ahead and cross that out. Oops. But I have this 8 factorial I need to go ahead and do all the way out, right? So 8 times 7 times 6 times 4 times 3 times 2 times 1. And Miss Kate's is not going to put that all in her calculator because I'm going to use my free graphing calculator at www.desmos.com. I'm going to click here on my function button. I already clicked on stats and then I'm going to hit CR, and then I know that it was 20 chosen 12 ways. and it gives me that it will be 125,970. So, oh, that's what we got here. So 125,970 different ways, different 12-person juries can be chosen. All right, let's take a look at 4. It says, how many different ways can you choose 3 types of flower for a bouquet from a selection of 15 types of flower? So again, it doesn't matter the order. So if I have a red and a blue and a green flower, it doesn't matter if I choose the green flower first or the red flower first. The order does not matter. So this would be a combination. And like I said, I apologize. The book does not do a good job of explaining that because the permutation doesn't talk about order at all. The permutation example. So my N, there are 15 objects, right? And I can choose it as a group of 3. So there's 3 ways I can choose it. So that would be 15C3. And so that would be 15 factorial over 3 factorial times 15 minus 3 factorial. I'm going to have to come down here. So that's 15 factorial over 12 factorial over 3 factorial. Oh, this is going to be an easy one. So I have 15 times 14 times 13 times 12 factorial. I can stop there. 12 factorial crosses out. So I have 3 times 2 times 1. So I will multiply that out. Find out what it's equal to divided by 3 times 2 times 1 is 6. I know that one. Let's do this one. 15 times, oops, let me clear. 15 times 14 times 13. Okay. It's 2730 divided by 6. It's 455. Notice that combinations are less than permutations. Why? Because the order matters, right? So we like crossing out those things that repeat themselves. So if I have red, so let's say for example red, blue, and green, green, blue, and red, blue, red, and green, I can cross these 2 out. I don't have to repeat those, right? So that's why combinations are usually smaller. Let's check us out in Desmos to make sure we did it correctly. Or I did it correctly, but you guys helped me in spirit. So 15, 3, 455. And I hope that this helps.